Good afternoon everyone and welcome to the Voltimum webinar series. My name is Kevin Valnagel from Performance in Lighting and I will be your presenter for today's topic, the State of Lighting, Nominal versus Real Performance of Luminaires webinar. If you have any questions, please use the chat box on the left hand side and they will be answered probably after the webinar. Maybe if there's something that we can quickly address during, we'll address it during. We might commence now. Just a note on my presentation, it's designed for a general audience. So my apologies up front to the experts who have joined, who are looking for some really deep insights. Mine is more for a general audience. It's in three parts. I'm looking at some background information to set the scene. We'll be looking at LED performance, which is a critical thing at this point in time, and then I have 5 quick examples. So we'll just get into the presentation with some background. Now hopefully you can see on the screen the 15 watt. Some people call this the energy saver. It's a ubiquitous thing that's come out over the last 7 years. Now, this is quite a striking example. This is the 380 watt, and they're good things to compare just to start off my presentation. So the 380 watt has 25 times the wattage, but does it have 25 times the light? What do you think? 25 times the light? Not quite, no. It has 50 times the light. So just quickly, the humble energy saver, probably not such an energy saver because the 380 watt is actually twice as efficient. So the first point I'd like to put on the table is that watts is not a good metric for light output, a critical thing. If not watts, then what is the thing that we should use to judge between things? I've got on the slide there a number of technical parameters, but lumens is really the one that the industry is using at the moment. Now lumens is about the flow of luminous energy, the light that comes out of a luminaire. That's really the important thing that we need to judge. It's not about light that's bouncing off a surface. It's not about what a light meter might pick up at a point in space. It's about the light coming out of a luminaire. Comparing light sources, pretty important thing, but efficiency is also important, so the energy and the watts matter is still there. So watts as a measure of power is still useful. The trick though is to divide lumens by watts. Then we can compare the ratios. The higher the number, the better. In the lighting industry there's this term called efficacy. For a general audience, think efficiency. Efficiency equals lumens divided by watts, and that's a good measure to compare light sources. Just to set the scene for some of the technologies that we'll be talking about, I've got a bar chart here with 4 different types of light source. They're all white light sources, and the numbers that I've got are lumens by watt. On the left you've got the humble incandescent light bulb that's been banned for a number of years now, 12 lumens per watt. Not a very efficient source of light. Probably generates more heat than light. The next one along is the humble energy saver that we spoke about just before, the compact fluorescent spiral bulb, 15 watt. It does about 15 lumens per watt. Then we've got the metal halide lamp, 70 lumens per watt. Now you can get good ones and you can get bad ones, but just a general metal halide lamp, 250 watt, we'll just say 70 lumens per watt. Then we have the T5 fluorescent tube, common thing that you'll have in your office lighting in the ceiling, 28 watts, about 100 lumens per watt if in a good temperature control environment. So it just sets the scene for efficiency between some of the known light sources. Now we can start to talk about LED performance, which is really the important thing for today's topic. It's important to have independent data to really see what the state of the art is. In the United States, the Department of Energy has been doing some long-term testing of LED luminaires since 2009 under a project called Caliper. It's tested actually about 30,000 luminaires, so it's got quite a database of information. Now, the whole reason the US government has been testing LED luminaires is it believes that they're important for the future, but there have been many bogus performance claims of boasts of long life and huge lumens per watt performance when the actual luminaire probably doesn't perform. So caliper's been testing to determine what the actual unbiased truth is, and it tests to the IES standard called LM7908, which reflects the actual light from a luminaire. So it's not a bad testing program for us to look at to see what the state of the art is. And I have the latest data here. It's been testing from 2009 up to, I've got Q2 data, 2014. Now what you can see is that the current mean for lumens per watt performance for LED luminaires, this is the outdoor area lighting series, so not all LED luminaires but the outdoor area lighting, it's 85 lumens per watt, which is actually quite good performance compared to the lumens per watt performance of the other light sources that we saw. It started out about 40 lumens per watt, so it's a bit more than doubled over time. However, there's a bit of an alarming issue in the data. Is 85 is the mean, but there's a huge spread of performance from probably way below what an incandescent light bulb would do, the bad one, right up to over 140 lumens per watt, probably for some very expensive luminaires, but this shows the spread. So the rub from this is if you're a buyer or a specifier, you really need to choose very carefully. You can get some lemons down here and you can get some very nice products up here. So why such a range of performance? Remember, we're talking about the luminaire performance, how much light comes out of the lighting fixture, not the light source. Well, there are those two parts. There's the LED light sources, and they vary enormously by brand and design, and even grades within a production line. Also, if you look around the internet and to some of the blog posts, there's talk of counterfeit LED arrays too, which is something that you'd have to be conscious of. It does exist. Now, luminaires also vary enormously in design, components and workmanship. Excuse me. So, the key thing to take out of this is that the light source rating is not equal to the luminaire rating. Excuse me, I'll just get a glass of water. Now I'm back online. Now, what are the things that optimize luminaire's output? There's some things here that are a little bit different to normal luminaires. The first one is proper heat management. An LED is very sensitive to heat, particularly on the LED array itself. And if it overheats, the light output would drop by quite significant amounts, perhaps by 30% quite easily. The optics and the light direction control of the luminaire can affect how much light comes out. The LED driver or the power electronics behind the LED can really affect the efficiency of the whole system. The components and the quality of workmanship and the durability of the design. Interestingly enough, one of the things that causes LED luminaires to fail is simple things like cheap connectors and maybe water seeping in and then causing corrosion. It's a weakest link of the chain sometimes that causes the failure. So there's many things that a manufacturer can do to optimize performance. So in comparing luminaires, traditional luminaires, it's not so bad. People had a choice of different bulbs and tubes, and the performance of those lamps, published data was available. And then reputable luminaire manufacturers in turn quoted light output ratios, LORs, to talk about what percentage of light would come out of a light fixture from a lamp. However, the difference with LED luminaires is that the LEDs are hardwired into the fixture. If luminaire manufacturers quote only the LED light source specs, it's really not giving a good indication of field performance. So the comparison of luminaires is actually a big question. So what a number of leading brands are now endeavouring to do to counter the potential misinformation is that they're presenting two rating methods for their luminaires and publishing the data. First of all, they're publishing the nominal lumens, which is based on the laboratory specs for the LED light sources that are inside, and then they're also publishing the real lumens, and some companies might call this the delivered lumens, but this is based on proper testing of the luminaire's true lumen output. So you get a real indication of what the luminaire will do in the field. Now, I've given you that background. There's the LED modules and the performance is increasing quite significantly. There's the question of the luminaires with the LED modules inside and what's the nominal and what's the real data. Now just to give some 5 examples to show the difference between the two lots of data. The first one's a simple example. We've got what I've called a 9,400 lumen floodlight. Now remember, we've said that it's not so much the watts anymore, it's really how many lumens are coming out. In this case, if you're interested, it's 120 watts. Now let's look at the spread. This particular model of floodlight, the nominal lumens is 13,000, which is 110 lumens per watt, really good. The real lumens coming out, 9,400, 78 lumens per watt. So actually it's better than a typical metal halide lamp. There's a 30% difference, but still quite good performance. Now the issue here is if someone is quoting their competitor floodlight with say 10,000 lumens and someone chooses it instead of this one, they would be making a big mistake, because by the time their nominal lumens were derated, this would be superior. So you could make a mistake. Another example, now we have some of these newer fixtures coming out where they're purpose designed for LED modules, and you couldn't do this before with other light sources because of the compactness of the lamps weren't there. Now this particular one, it's over 3,000 lumens. It's designed to be a pole top, say 2.2 metres high. For your interest, 45 watts if you still want to use the old style. Now, this particular one, interesting because there's zero upward waste. It just throws the light down to where it's needed. So traditional fixtures throw a lot of light up into the sky and it's wasted. This one can be more economical because it's just throwing light where it's needed. So in this particular example, the nominal ratings over 5,000 lumens, the real lumens 3,000 or so. So it's 38% difference. But the key thing here is that even though some of the light is lost going through the lens and being operating from the luminaire, it's actually twice as efficient just from the design compared to a normal pole top opal sphere. So very efficient just in the design, let alone in the lumens per watt performance. The third example, we've got a humble bollard, garden bollard, provide orientation lighting in a landscape. This puts out 650 lumens. Not a lot of light. And its performance is 40 lumens per watt. So you might say that's not very good. But the interesting thing here is that it's quite a complicated optical chamber here, bouncing light up to put a nice gentle flow of light downwards to provide just a nice glow at night. And whether you've got a HID lamp in here or a fluorescent lamp, it's just a very inefficient design for that purpose. So if you derated those other technologies by a similar amount, you'd find that everyone's subject to the same difference between nominal and real. So it's an interesting example based on the type of design, but it does a job. Now, the fourth example, I find this very interesting because I showed you that T5 fluorescent tubes doing about 100 lumens per watt were actually quite a good light source. And the interesting thing is, how do LED luminaires compare? I've got a good example here. It's a 53 watt LED linear weatherproof product. Produces 3,800 lumens, real lumens. Now, we've got a comparison here because the same luminaire is available in a T5 model. Now, what's the comparison? Well, the LED has the higher real output based on lumens per watt, a real true comparison measure. The T5 fluorescent really only does 59 lumens per watt based on the testing versus 71 lumens per watt for the LED type. So, the rub here is that the diffuse light of a fluorescent is a bit harder to tame than the actually quite nice LED light, which is quite directional and can be directed to do a particular job. So even against fluorescent products, LEDs at this day are quite good. Just one last example with street lighting. Street lighting can be quite an to meet some of the maximum pole distances with the specifications can be quite a challenge. So I've got a street light here. It's a 30 watt street light, produces about 2,600 lumens. It's actually quite efficient. It throws most of the light from the lumen array, the LED array out of the fixture. It only loses about 12% going through the glass and the optics and whatnot. But this particular one, 30 watts, it will meet the maximum distance spacing 40 metres based on the P3 standard at 6.5 metres height. So this is a common requirement for people to sort of to have. Now, interestingly enough, this can achieve a 30 watt fixture. Generally, the competitors with metal halide will need a 70 watt lamp to meet the requirement. So, and it's one of the reasons is metal halide lamps come in increments, and 70 watts is a typical increment. But once again, LED beats metal halide and does it very nicely. So a very positive story for LEDs, but you can also see the difference in performance, nominal to real. So just in conclusion for today's session, real versus nominal really does help with choice. What is a good luminaire? What is a not so good luminaire? And it's not like some of the older technologies where the difference wasn't that great with LED products. Looking at that United States Department of Energy data, very, very great spread. So it's very, very important to show a difference between real and nominal. And leading brands are now providing this information. Those products without the adequate credentials really do need to be treated quite cautiously because of the spread and performance. And I would encourage people to sort of really look at the data before choices are made. Now, thank you for today's presentation. I will take some questions if there are some and provide answers. But I would like to thank today's viewers. They've tuned in to the Voltiman webinar, and I will be toggling to a 30-second survey soon if you'd like to participate. But I'll just wait a few minutes in case someone has a question that I'd like to put through. I'll just toggle through to the survey, and I do encourage you to fill out this 30-second survey. It'd be valuable feedback for Voltiman. And thank you once again.